Thank you. Testing, testing. I think people can hear me. Although, I do not appear to be mirroring like I'm supposed to. Arrangement, mirror displays. And now you are seeing the slides. That's probably useful. Probably more useful for you to see them than me. OK. I hope you enjoyed my dance moves coming on. And I want to remind you that Mr. Chopin was not carrying a laptop and a full glass of water when he was doing that dance. So normally I'm way better than him. Just want you to know. We'll have a dance-off later at the after party. So this is about visualizations using SVG, Canvas, and WebGL in Vue. This is a little screenshot from earlier in the day when Guillaume was talking about the Vue UI and showed off briefly this little chart that dives into what's taking up the most space in your dependencies, when you have a really big build. And as you can see, there are a lot of interesting shapes, like circles with bits carved out of them, and then little parts of circles in order to allow you to dive into exactly what's going on there. And there are hover effects. It's interactive. This is an image, so this won't be interactive. And you can click through different folders to get a more fine-grained view of what your dependencies look like. And this is a great example of the power of visualizations, making it really easy to traverse data and making it really easy to answer questions about the data. Now I'm going to introduce myself. Hi, I'm Chris. I'm on the Vue team. I've worked on a lot of documentation, and I'm also on the Views on Vue podcast, as they mentioned. And I also try to do a lot of design work for Vue itself in terms of helping design the API and a lot of other things in terms of events and just trying to make the ecosystem better, trying to help out in any way I can. My goals for this talk are to first introduce why it might be useful to visualize things using these technologies, expose you to what it might feel like, what it looks like to work with these technologies, show you some tips and tools that I find really useful, and then also give you a playground so you can play around with this stuff. My goal is that at the after party, everyone will have a drink in one hand and their laptops in the other as they try to play with how they might create a really cool visualization with SVG, Canvas, or WebGL, or some of the tools that I'll be showing off to help you build really beautiful things. And how many people have had a really great feeling? Just give me a shout when you've built something really beautiful and you just want to show it to someone else. Yeah. All right. How many people have spent 1 hour building the thing and then 2 hours playing with it? Yeah, I've done that too. I'm guilty. So first, before I go into these other technologies, I want to talk about HTML. You can do a lot of really cool visualizations. You can make a lot of different shapes just with HTML. Here I've made a rectangle, a gray rectangle. Not that cool? I am using, listen, I'm not trying to show off, and I don't want to get too technical, but I'm using a div with a class, and then I have some CSS attributes on it. You can check out the code later. It's pretty complex. And you can also make circles using border radius with HTML. Again, not trying to show off, but I'm pretty good. You can even make triangles. Now, this is getting a little more hacky. Here we have a transparent border left and border right, and then a border bottom that happens to make a triangle with something that technically has no width and has no height, so maybe shouldn't even appear? But it does, and we can use that. We can hack that. How many people have hacked something like this to make a triangle in HTML before? Yeah, all right. And you can make some other shapes too. You can make a line if you make the rectangle really thin. And you can rotate it with transforms and things like that in CSS. But there are some limitations. Sometimes you want precise shapes. For those who aren't familiar, this is the US. I came from right about here just a few days ago. And this is highlighting all the counties in the United States. Now, I don't know about you, but personally, I would not want to build this with divs. That might be a little bit of a pain. Sometimes you also want really high performance. You want a lot of things happening on the screen all the time, and you want it to happen quickly, like in this case, 60 frames per second. How many people know, actually, if someone knows what visualization this is, go ahead and shout out. Conway's Game of Life, that's right, yeah. Sometimes you also want to do things in 3D. This is a little demo I made for another conference, Vue.js London, where the logo is split into a bunch of three-dimensional pyramids and then animated to twist about and do cool stuff. This is one of those examples where I spent maybe like 3 hours building it and then 5 hours playing with it. And you also want to remain dynamic and interactive. So this is something that I didn't build. This was built by Sarah Drasner, who is at least here in spirit today through her incredible demos. So this is a little like Wall-E type character who is just longing for this cockroach that my mouse cursor is turned into. And this is an SVG that is changing based on my mouse position and some other rolling animations. This example is available in our docs in the state transitions page, by the way. So here's where we get into those other technologies, SVG, Canvas, and WebGL. First, SVG, you might notice, looks a little bit like HTML. We have elements. We have an SVG element and then a rect element. And the rect has attributes like x and y, width and height, x and y being the position on a grid from the top left corner. So we're 10 to the right and 20 down. You can also style SVG elements with CSS, but the attributes look a little bit different. As you can see, instead of background, we have an attribute called, or a property called fill. We have stroke and stroke width instead of border. So this will be very similar. You select elements the same way, but the way that you style them is a little bit different. And just like with HTML, you can use it with Vue to create something dynamic and interactive. So this is an example where I have a box inside of another box. Again, not trying to show off. That I can move around in the box and change the size of it. I'm keeping this very simple for a reason, just so you can see how we can use directives like vmodel. We can use bindings with vbind. And all of this is driven by data, defined in my data, and computed properties. And that's it. So if you're already familiar with HTML, SVG is actually pretty easy to use with Vue in the sense that you know how it fits into Vue. It's just elements, just more kinds of elements. Now, SVGs can also have a lot of different shapes. So unlike the squares and circles and triangles and, straight lines, we can build these wavy lines that go in all different directions. These are polylines. We can make shapes with sides, polygons, and we can even make really curvy lines. And making a line like this is a lot less hacky than what you'd have to do the same thing in HTML. So once again, we have an SVG element with a few recs to create these first two shapes. Then we have a circle and ellipse element, line, polyline, that's the one that goes jagged, polygon to make the shape with many sides, and a path. And so some of you might be thinking okay, this starts to look pretty complicated. How do you come up with these numbers? 60, 110? Oh, and I just clicked on it. By the way, this is actually kind of good. All of these examples that I'm going through, if you click on any of them, when I share the link to the slides at the end, they'll open up in Code Sandbox where you can edit the examples and play with them yourself and experiment. So these slides are actually a sandbox where you can keep playing and experiment with these tools as you're using them. So you don't have to memorize all these things. There are tools that I'm going to show you soon that will help you draw lines and automatically create these numbers so that you don't have to do all the math. There's probably only one person who can actually just from their head pull these numbers and draw something, and that is Sarah Drasner. And again, we're using CSS to style all of these elements. And as you're working with technologies like this, I strongly recommend prototyping as you learn. This is another example on the state transitions page of the Vue docs, and also another example where I spent maybe an hour building it and then 10 hours playing with it. So this is just a polygon inside of a circle, and I can change the number of sides, and I can change the minimum radius, and I can change how the animation works, the update interval, so it's really slow or really fast. And in doing this kind of thing, I often realize the things that I could create that I never thought about before. A lot of people might not imagine all the different variations that you can build with this, just with a single element, a polygon. And I'm not going to show you the full code for this, but it is available in the slides, and again, if you click on it, you'll be able to play with it. I'm going to point out a few things about it, though. First of all, for the animation, I'm using a tool called GreenSock. The GreenSock animation platform, GSAP for short. We also do a lot of demos for this on our state transitions page, which you can see a link to on this slide as well. Anything that you see underlined is actually a link that you'll be able to click on and check out more information on when you're checking out these slides later. There's also a little bit of actual math in that demo. How many people went to school and their math teacher told them, this trigonometry, is really important. This calculus is really important. You ask, what am I actually going to use this? And they didn't really have a good answer. How many people had that experience? Raise your hand. Yeah. Okay. So some people didn't go to school. Okay. I think most people have this experience, and the answer is this is when you use it to make beautiful things. Sometimes you use a little bit of math. Fortunately, if you don't remember that trigonometry, you can brush up on some stuff. And there are tools that I'm going to show you that can do a lot of the math for you. Now, unfortunately, while SVG allows you to do a lot of really cool stuff, it is slow, like HTML. So here's our Conway game of life visualization again. And we're getting a good 60 frames per second with 5,184 cells. I'm going to increase that a little bit. OK, 9,216 cells now. And we're dropping down to maybe 32 frames per second, stabilizing it around there. And this is also one of the newer MacBook Pros, which, if you're building something for clients, you probably can't rely on them having the newest hardware. This is where performance becomes really vital. But before I go into how to make more performant visualizations with the other technologies, I want to walk through a few tricks that I've used for the SVG version to make this as fast as it is already. And some of these may not be obvious. For one, for elements that are removed and added over and over again, instead of conditionally rendering them with a v-if or a filtered array with v4, I actually use vshow to just toggle display none. And that's much faster than constantly removing and adding elements to the page. I also cache-derived values with computed properties. Now, the grid width times grid height multiplication, this isn't going to create a huge performance optimization. But in many cases, you do have complex calculations that you want to make, and you only want to rerun those calculations when the data those calculations rely on actually changes. You'll also, if you set up any infinite loops, you'll want to clean them up before the component is destroyed, or else you'll have a memory leak. So for this evolve function, this runs infinitely. So what I do is I just reassign it to a no-op function, basically a function that doesn't do anything. And then it can be garbage collected. And inside of the evolve function, you'll see that I'm not using an infinite recursive function, so a function that just calls itself. And I'm not using something like setInterval to just run something every millisecond. Instead, I'm using a tool or a browser API called requestAnimationFrame that will run this as long as as many times as the browser can keep up. So you don't get situations like skipped frames. And it'll just go as fast as the computer is capable of. Now, fortunately, Canvas and WebGL are faster. Here's that same visualization with Canvas. We're at still 9,216 cells, but we're still at an easy 60 frames per second. So I'm going to boost this a little bit, try to push our limits. OK. Now we're at 230,000 cells. And we're finally starting to see some slowdown. Now, Canvas is not XML-based. It doesn't look like HTML. We have a Canvas element here. But after we add that Canvas element, we use JavaScript to, line by line, give it instructions about what to do. It's imperative rather than declarative. So we get that element, and then we get its 2D context. And I clicked on it again. And then we tell it to fill style with this color. That's how we tell it what color to draw in. And then we tell it to fill a rectangle with these coordinates. And once again, very similar to SVG, we have an x, and then a y, and then a width, and then a height. Except we have to remember the argument order instead of being able to just tell it what we want, which is a little bit annoying. And to make this performant in Canvas, there are a few other optimizations that I want to show you. So first, you can see we're really not doing much in the HTML. We're setting the width and the height, and then that's pretty much about it. And as we recalculate the grid every time, I just watch for whenever the grid changes. And whenever the grid changes, I clear out everything and then draw what I need to, draw the cells that actually exist. Now, it might be counterintuitive that it's actually faster to clear out the entire screen rather than going through and only rewriting the cells that have changed. But in this case, you actually want to minimize the number of operations that you're performing. And this is the best way to do that. You'll also notice that instead of for each or map, I'm using a for loop, which is much faster in JavaScript. Normally, in most applications, you can use for each and you can use map, and it doesn't matter. It doesn't matter in almost every context. But sometimes, in cases like this, where you're running an operation over and over again, or with a very, very large array, it can be useful to use a for loop instead. So now, how would I do this stuff in WebGL? Here's my fancy gray rectangle again. To make this gray rectangle, I've defined a vertex shader and then a fragment shader and a special shader language for WebGL. I have my canvas element again, just like with SVG, or just like with Canvas. And then I just go through a few things to draw my rectangle. And now you might be thinking, this seems pretty complicated. It seems like a lot of code to just draw a rectangle. And I want you to know it's not always this complicated. It's usually much, much more complicated, because in this case, we're just drawing a rectangle. So writing raw WebGL is not fun. I did not spend a lot of time playing with this after I finished. And I was very frustrated having to learn even just how to put something like this together when I first started using WebGL. So I would avoid it, if you can. Instead, use libraries like 3JS, A-Frame, and Mapbox.gl, which are great libraries that offer abstractions on top of WebGL that are much easier to use. Okay, so why use WebGL over Canvas? They both seem fast, and Canvas seems like it's a lot simpler. The answer is 3D. Whoa! It was 3D the whole time. Okay, this is one of those cases where I spent a lot of time playing with it afterwards. And my wife asked me from the other room, why are you making those sounds? I told her the sounds are important. And she asked me when I was demoing this talk, you're not going to do the sounds when you really give the talk, right? And I lied. So creating 3D with WebGL with A-Frame is actually much nicer. We're back to using just elements. A-Frame is a project built by Mozilla, by the way. And so now to create our square, we just have to create a scene, a plane, and I clicked, and I'm going back And then we have a camera to define where we're looking at the box from. And once again, we can go around it, and the connoisseurs among you might notice a delightful little like light source, beaming down, which is lovely. That there's a default light source for A-frame, and you can also override it and define your own. So now we're getting a little bit fancier. And this is another demo. This is that demo that I was referring to earlier. And this is on CodePen, which I think you heard a little bit about earlier. I hope you remember. CodePen is, Code Sandbox. Yeah. I know what it is. I just said it wrong. The static examples are in CodePen, and the more complex ones like this are in Code Sandbox. Thank you for correcting me. So this is something that I spend a lot of time playing with. And you can check out the source when you're looking at the slides later with a drink in one hand and your laptop in the other, very carefully. I hope to see a lot of nerds later. So now some general tips and overview. First, I want you to keep in mind that dev is slower. When you're developing some of these visualizations, you may think at times that you have a performance problem, but the performance problem might only exist in development. And if you actually compile your code for production, you'll find that because of the optimizations that Vue and every other framework makes for production builds, we're not checking to see if you're making certain mistakes so we can give you warnings and stuff like that. We're skipping all that. That you might find it's plenty fast in production. So I've had this before where I and other devs have spent like a whole day trying to fix a performance problem that wasn't reported, but we found it ourselves while we were playing around with it. And we decided we were going to fix it. And then we submit it, and they ask, like, why did you spend all day working on this? No one has this problem. And then instead of feeling like a king or some kind of god, you just feel very foolish. King or queen, sorry. Or goddess. Although, how does it go both ways? I don't know. Also, like I said, optimize repeated operations. Use functional components when you need to render the same component many times. And use vshow instead of constantly adding and removing elements. And you can also componentize imperative code. So if you do want to write some raw WebGL, but you don't want everyone on your team to also have to write raw WebGL or even to know about Canvas and things like that, you can write components like a WebGL Canvas component and a WebGL box component that hide that functionality so that your teammates can build really incredible things using these technologies without having to be WebGL or Canvas or SVG experts themselves. And I highly recommend looking into the provide inject feature. Again, this is a link to the Vue docs, which is really useful for creating these kinds of interfaces. Overview of libraries. There was GSAP for animation, really, really cool. A-frame for 3D to make the WebGL just elements that we can drop into our HTML and into our templates. Or there's also a project called vuejs.amsterdam that builds off of, instead of A-frame builds off of Three.js, vuejs.amsterdam builds off of Babylon.js, which also uses WebGL to create really cool things. And I think it's more often used for games and stuff like that. And you can use D3 for math utilities. This is a really great library that you can, or it's a collection of libraries that you can download little pieces of when you want to do very specific pieces of math. So you'll still have to describe what you want to do, like fill an area underneath a graph with D3, and you type that into Google, you'll find examples of how people do that with D3 utilities so that you don't have to brush up so much on your trigonometry and calculus for those of you who did go to school. And very, very important, you have to have fun. So build things that you'll want to waste time playing with. This is so important. When you're having fun, you can push past the frustrations, and sometimes these things can be very frustrating. The APIs aren't always the most fun to deal with. And use a lot of animations. This is an example of how easy it is to create an animation with GSAP. Also, please, this is the awkward part where I put a hat in front and ask you for money. Please support me on Patreon if you like the work that I do at patreon.com/crispviewfritz. I want to give a big shout out and thanks to John Leider from Vuetify, and also from Ralph Haug from Vue School, who are my Vuesionary level sponsors, who give me more time every single week to work on Vue and to work on things that make your life easier. I'm Crispy Fritz on Twitter. And by the way, my pinned tweet right now is a few workshops that are still available in Oslo, Zurich, and Madrid. How many people we got in those cities, coming from those cities or those areas, general areas? Yeah, woohoo, woohoo. People are not excited about their cities. When I watch Netflix, when people say hello, everybody who are from a place, everybody cheers. Why isn't that happening today? I guess it's tired. People are tired. Okay. So people from Oslo, Zurich, and Madrid are very laid back. People in Madrid already on their siesta. So again, you can find out more information about these workshops if you go to my profile, twitter.com/crispyfritz. You can check out these slides at fritz.netlify.com/slides/visinview. And thank you.